this problem that you voted off the island came from an old exam. It was the first problem on the exam. It was intended to be a gimme. It was intended that everyone would get it right and feel warm and fuzzy. That's not the way it turned out. Okay, that's not the way it turned out. Now, we have Tarzan starting from rest, 5 meters above the water. He swings down, releases, and flies through the air. My question to you is, true or false, energy is conserved in this problem? True or false? Okay? True is the correct answer. We came really close to having 100% there. If we think about what would do work, well, the Tarzan swing, but it's always pulling along the vine, and Tarzan's always moving perpendicular to the vine. So by our definition of Varric, that's zero Varric. If we ignore air resistance, and we always do, then there's no loss of energy due to air resistance. And so we can use conservation of energy. Now initially, all of the energy is gravitational. Tarzan's not moving, and there's no springs in this problem, and so that is the total energy. If energy is conserved, then right there when he lets go, I still have the same amount of energy. But now it's divided between two buckets. If I look right before he hits the water, right before he hits the water, right before he hits the water, don't let him hit the water. If he hits the water's doing a whole bunch of negative Varric on him. That's hard to calculate. That's really messy. You want right before he hits the water, how fast is he going? If energy is conserved, and it is, and all of that energy is now in the kinetic bucket because he's down at height 0, then I can figure that speed out. Now here's the problem. When we put this on an exam, we gave them those 2 meters. And everyone in the class felt they ought to use them. Well, the point we were trying to get at is that if you want information here, and you know everything about the energy there, make that your initial and that's your final. And you do not have to care about anything that happens in between. If he's really good, he can do a triple flip with a full twist. It doesn't matter. It affects how much fun he's having, but it doesn't matter to the final answer. Now, here's what many, many people did. They used energy to figure out how fast he was going here. Pretty straightforward. But then they used a whole lot of trig to figure out what angle he was going at. Then they turned it into a projectile motion problem with very ugly numbers, and they got lost. It took them a whole heck of a lot of time when they should have been working on the rest of the test. What they needed to do was just say, the gravitational potential energy there is equal to the kinetic energy there. And because they both have a mass in them, the mass cancels. And if I solve for V, I just get a very simple answer, 10 meters per second. See if your neighbor followed that.